Don't cheat. Close your eyes, please. Okay, now we do something. Okay, now you can open your eyes. Can somebody tell me what you think I've been doing? Okay, and did you hear? Was it correct? Yeah, a little bit, but it was halfway. Can somebody tell why the answer was only partly correct? So in here there was a nice example because you really did you ripped a piece of paper.
You really ripped it by using your teeth.
Exactly. So I just ripped it by using my mouth and my hand. So what do you think it happened actually? Why you thought that I was doing it like this?
It's more frequent. Usually we are doing like
exactly, this. Because this is exactly how we know how we would do it. So basically what I will try to argue is that this mirroring might actually be a projection of self. And then in another example, for instance, if it's your birthday and I come like this, right? That's the same, you would expect me to give you something. But what would happen then? For instance, if you never had arms before, and I come like this, and you are born without arms, what would we would expect? So here is the example, and we had the opportunity to work together with two people that were actually born without arms. And they did not have any stump or anything. They was really without limbs completely. And for the rest, they were normal people where they were really doing normal things that we would do. One of them was actually a computer programmer. But how they would do it is just using their feet. So they would come here and shake your hands like this. Nice to meet you. And they could even oppose the thumb and the index, but with the feet. It was really amazing. And then we asked them basically to come into the lab, and we showed them movies, as I showed you before, of everyday actions performed with the hands. And we also, of course, asked them to perform actions with the feet and the mouth and the control also with the hands. So here you see all our subjects. Which one do you think are the two aplasic participants? I numbered them so you can just tell me a number. Come on. 5, yeah, that's also what I think I was also. Then, not the second one? Yeah, exactly. That was also our, what we expected. We expected to find a reduced activity. And what we actually found is that these two basically are the two aplasic subjects. So they had a completely with normal activity in the brain while watching the actions of other people perform with their hands. And what it means? It means that the actions that we showed, they were really familiar actions, right? They were like, again, putting a CD in a CD case, watering a plant, and buttering a bread. All these actions, they knew, right? They were really familiar with these actions, but just that they would not do them with the arms, but with the feet. Or the mouth in some cases. So basically, when they watched these actions, they really activated areas of the brain that they were used to perform these actions. And in their case, the mouth and the feet representation moved a little bit into the hand region. So that's why it's also in the very same location. So as a take-home message in a way, I would really like to think of this system as really like an intuitive and very spontaneous way to grasp what's happening in the other people, but through your own experience. And indeed, if I argue that the experience is important, can we then learn to be mirror in this case? And the answer is definitely yes. So they made an experiment here in which they had people listening to such a melody, very simple one. And they had people that were naive. They've never played the piano or an instrument before, and people that played the piano before. And at first, this is what they found, is that naive listener had mainly auditory cortex lighting up when listening to these sounds, which makes sense because they were listening, right? But there was not much of the shared circuits area, like the premotor, for instance. But 5 hours of training, just letting the subjects training the melody on a keyboard, was enough to finally activate the premotor cortex. Okay, so the answer is yes, I think we can learn. And if you also look at the animal work that has been done, they've also been using things like the duck or the paper or other actions that the monkey does not normally do, maybe in a natural environment. So, I mean, it makes sense that it's not all innate. Okay? And how basically this learning can happen. So I try to give you a very simplified version of our model of how we can learn to be mirror. So if we now assume the rat as a neuron in the premotor cortex that takes care of programming the action A, and now here we have a neuron, the black neuron for action B. Okay. So, then when you perform A, this neuron will of course become active. But then the moment you perform A, basically, you basically see what happens as a consequence of this performing A. And this information, for instance, here's Julia watching herself grasping the watch. So you really see, so she sent this neuron of grasping, was activated. At the same time, she was watching herself doing it. So this information goes into the brain, and it goes to all the primary areas, of course, and then secondary visual areas, and so on. And then the parietal, it will go on. And then here, what happens is that if this neuron is connected to both at first, okay, this activity will coincide with the activity of these premotor neurons, but not with the neuron of action B, because Julia is performing action A at that moment. And basically, this connection, as a consequence of this activity that happens at a similar time, will be reinforced. Okay? And so on and so on. And this is basically an easy way in which we could really learn this type of association. And of course, nature doesn't really leave this as to chance, because the baby attention is really driven by, it's really, let's say, meant to really, the baby is meant to watch itself. Yeah? It's really, all these actions at first, they're really important. And the moms, also the behaviors of the parents is really towards the baby, much more than what is normal. And this is what actually nature could really prime us. Instead of really building all these neurons already like genetically predisposed, I think it's much easier if nature would simply set up a mechanism that would kind of be self-sufficient. So not all mirror neurons need to be inborn, and of course you probably have heard of the tongue protrusion case. We don't know what it is, probably that is maybe one of the few inborn cases, but still more research needs to be done. And then again, mirror neurons could be just a byproduct of motor control and synaptic plasticity. Okay, now I just go away from the action domain for a moment. Although, if we consider actions, like they are rarely just neutral actions, right? When we act, it's the times in which we are neutral are really few. Most of the time, actions also carry like a consequence, like a sensation, or they are really emotional. If you're stunned, I mean, you can really see me the moments in which I'm doubting, or I'm more secure, or if I'm more anxious, based on also the type of movement that I do. So now look at these examples, for instance. How do you feel when watching this, or this? although we probably did not experience, at least this, I hope for you, we did experience something similar. Maybe a fish bone or that we ate was a bit unpleasant, let's say, and also we probably stepped on something that is kind of similar to that. So we can easily have this sensational aspect also while observing these images. And what about this? This is what I think it's an interesting case, right? Because if we would really project ourselves, it would be very painful. But I think we can somehow then compensate this first reaction and clearly see that it might not be painful at all for the cat. So what we have been doing that in the lab was asking people again to come in the scanner, and we show them movies of 2 times. Again, in one case, there was a rod touching the leg of the participant, so in this case of the actor, and in the control condition, the rod was moving beside the legs, but was not touching the legs. And then again, we actually let the subjects really experience that sensation. So we kind of had a brush, and we touched the leg of the subject to identify the area that really responded to the touch. And here in blue, what you see is an area that responded more to the observation of touch compared to the control condition. In red, you see the areas that respond to the experience of touch. And again, you can imagine what I'm going to do now. We overlap them, and in white, you see the areas that were actually activated both by the experience of touch and the observation of touch. So you see that again in the brain, you can find places in which the own experience overlaps with the observation of the experiences of others in a similar way that it happened for actions. And this is happening actually in somatosensory areas, so it makes us a lot of sense. And what about emotions? No? Actions, we have it for sensation, and what happens with emotions? So from what glass would you drink? Let's see. I think you would all drink from this, right? Or maybe from this, but not definitely from this one. So we can discuss whether it is an emotion or not, but it's definitely what some people consider one of the primary emotions. And they are easier to study in the scanner because, of course, to say somebody to be happy, it takes, there is not so much control about what's happening in the subject. So we started from something simple, and we also had our subjects basically experiences those smells. So we had strawberry and mint smells as a pleasant and disgusting smells like butyric acid, so it's like rotten eggs kind of smell. And that is the rancid butter, and then this one that is like the rotten eggs. So they were really disgusting. We had to actually take one subject out of the scanner because it was almost throwing. And I was one subject at that point, and I can guarantee you that it went fine, especially for 45 minutes. Anyway, so what you see here in red are the areas that were more active to the disgust smell compared to the pleasant one. And in blue is basically the areas that were responding more to the observation of somebody that is disgusted compared to somebody that was not. And again, usual story, we found areas that were basically active both during the experience of a disgust smell and the observation of somebody perceiving a disgusting odors. And this was actually happening in the anterior insula. This is really an area that is meant to take care of our emotional states and visceral states.